Hello, my name is Mark MacLeod, and I'm recording this talk in advance of the 2026 Clan MacLeod gathering in Parliament on the Isle of Skye. I'd like to acknowledge my co-authors, Andrew Piers MacLeod, the MacLeod Clan Genealogy Coordinator, and fellow admins of the MacLeod DNA Project, Colin and Rod MacLeod. The focus of the talk today is to show how we can use DNA to learn more about Leòd's ancestors and descendants. If you are a MacLeod, you may be one of these descendants. The theme of the 2026 gathering in Parliament is Hold Fast to the Honor of Your Ancestors. So, do you know who are your MacLeod ancestors? As you'll see in the talk today, DNA can often help you identify your distant MacLeod ancestors, and Leòd just might be one of your ancestors. We have a lot to talk about today. In the introduction, I'll present a high-level overview of the science of DNA and the DNA of the entire MacLeod clan. In the main part of the talk, I will dive into detail on the DNA of Leòd's ancestors and descendants. Next, I'll speak about what are called non-paternity events, or NPEs. And finally, I'll make an appeal for more DNA testing of MacLeod men. Let's start with a brief biology lesson about DNA and chromosomes. This is an image of a man's 46 chromosomes. You can see that they are all arranged in pairs, so he has 23 pairs of chromosomes. One half of the pair came from the man's mother, and the other half came from his father. This is why this man shares traits from both parents. The first 22 chromosome pairs are called autosomes. Remember this for when we talk about autosomal DNA tests. In the 23rd chromosome pair, the so-called sex chromosomes, we can see that this man has an X chromosome, which he inherited from his mother, and a Y chromosome, which he inherited directly from his father. Today we'll talk a lot about this Y chromosome and the details of the inheritance. Exact copies of these chromosomes are found in every cell in this man's body, and they contain his DNA. The man's DNA is like a biological blueprint with genetic instructions that were passed down from his parents to make him who he is today. If I could zoom up on one chromosome, it would look like a tightly packed skein of yarn, with the yarn fiber containing one very long DNA molecule. As we saw in the previous slides, the DNA molecule resembles a long twisted ladder, which is known as the double helix. Let's now zoom up on this man's Y chromosome and compare it to his father's Y chromosome. Here we see a schematic of the DNA double helix of a father and son's Y chromosome. Each rung of the ladder contains one of 4 DNA chemicals called nucleotides. When the son is conceived, he receives an exact copy of his father's Y chromosome, including exact copies of all the 4 chemicals on the roughly 60 million rungs of the Y chromosome ladder. However, on rare occasions, a copy mistake happens at one of the rungs. In this example, the chemical at one location on the father's Y chromosome was A, or adenine, and the son's chemical at the same location is now G, or guanine. The son will pass this chemical on to all his male descendants. I'll call this copy mistake a mutation throughout the talk, but yet it has no medical or physical consequence whatsoever. It's simply a copy error. It is this mutation event that we can take advantage of in genealogical work. Because they happen only about every 3rd or 4th generation, geneticists can use average rates of mutation to estimate approximately when in time a mutation event occurred. Okay, now that we have some understanding of genetics, let's look at 3 types of DNA tests. There are 3 types of DNA tests available today. This chart represents the family tree of a MacLeod man who has taken a DNA test. In the first row above this man, we see his parents, father on the left and mother on the right. Then we see his grandparents and great-grandparents on his paternal side and his maternal side. By far, the most common type of DNA test is called an autosomal test, which only looks at the 22 autosomes that we saw on the earlier slide. Companies such as Ancestry, MyHeritage, and Family Tree DNA offer these tests. These autosomal DNA tests will look at the contribution of the DNA from all the man's ancestors shown here and the ancestors before them. The next type of DNA test is called a mitochondrial DNA test, which evaluates the DNA passed down the maternal line. The DNA test that I'll be talking about almost exclusively today is called a Y-DNA test. As its name implies, it only looks at the Y chromosome. And only men carry a Y chromosome, so only men can take these tests. These tests are offered by a company called Family Tree DNA in Houston. Given that this man is a MacLeod, we can reasonably assume that the men in his paternal line shown here all carry the MacLeod surname. One goal of a DNA test is to determine if this man's paternal line leads all the way back to Leòd, the progenitor of the clan, born about 24 generations ago. As we'll see, only about half of the MacLeod men in our DNA project descend from Leòd along this paternal line. In this slide, I hope to convey how Y-DNA testing works. I learn best from examples, so here I'm going to share my genealogy and my Y-DNA test results to illustrate the concepts. These concepts are fundamental to the rest of the talk, so I hope you can follow along. Here is my paternal line. My father was Bruce, my grandfather was Gordon, and so on up the line to Norman, who was born circa 1785 on the Isle of Raasay. I took a Y-DNA test, and it showed that I have a harmless mutation on my Y chromosome that first appeared in a man born around the year 1867. Here I've called this mutation B. Well, my great-grandfather Ernest was born in 1876, so from this I believe that Ernest was the man first born with this mutation, and he passed it down to his son Gordon, who passed it down to my father Bruce, who passed it down to me. My Y-DNA test also showed that I carry a slightly older mutation that first appeared in a man born around 1745. These date estimates are imprecise, but mutation A may have first appeared in Norman's father, born circa 30 years before Norman. While developing my family tree, I discovered that my great-great-grandfather James had a brother named Lachlan, and from this I found that Lachlan had a living male descendant named Danny MacLeod living in the U.S., who was my fourth cousin. I contacted Danny and convinced him to take a Y-DNA test. Danny's Y-DNA test result showed that he carried mutation A, but not mutation B. He doesn't carry mutation B because he's not a descendant of Ernest, but he is a descendant of Norman and his father. One benefit of Danny's DNA test result is that it confirmed my family tree was correct. Both Danny and I carry much older mutations shown here. I'll talk about these specific mutations throughout the talk. As you can see, the first mutation appeared in Leòd himself. In summary, if two men or a group of men share a Y chromosome mutation, we can be absolutely sure they are the descendants of the man who was first born with that mutation. The Associated Clan MacLeod Societies, or ACMS, started the MacLeod DNA Project more than 20 years ago. Then in 2019, the testing company Family Tree DNA introduced a new type of Y-DNA test called Big Y, which completely changed the game. Using results from this new test, we see that most MacLeod men today can be placed into one of 5 genetic groups. The men in the largest of these groups are direct paternal line descendants of Leòd himself, who is believed to be of Norse descent. Another large group of MacLeods today are descendants of Celtic people. these people were likely living in Scotland long before the Vikings arrived. The next three groups are also MacLeods who are descendants of the Norse, but these groups are genetically distinct from one another and genetically distinct from Leòd's descendants. We believe these four groups on the left and right side assumed the MacLeod surname far back in time as they were assimilated into the clan. These five groups came together to form the MacLeod clan. Furthermore, as one would expect, these groups have intermarried since the early days of the clan, mixing their autosomal DNA. If we look at the distribution of the MacLeods that we see today in the project, about half of the MacLeods are direct paternal line descendants of Leòd. The MacLeods in this group are said to be in the chiefly line. That is, somewhere along their paternal line in their family tree, there is a MacLeod clan chief. Furthermore, as you'll see later in the talk, we have used Y-DNA to identify whether they descend from the Harrison-Dunvegan branch or the Lewis and Raasay branch of the clan. The focus of this talk is on the large group, the direct paternal line descendants of Leòd. Let's now look at the DNA of Leòd's ancestors. Most books on the history of Clan MacLeod start with a view that Leòd's father was Olaf the Black from the Isle of Man. Other authors, including Andrew Piers MacLeod, have claimed that Leòd's father was named Olvir, not Olaf, and that his great-grandfather, also named Olvir, was from the Hebrides, not the Isle of Man. This earlier Olvir, alive in the 1100s, was probably the same man as Olvir Rasta, a character in the Orkneyinga saga. So what do the genetics tell us about Leòd's ancestors? Here I'm showing the common Y chromosome mutations found in over 100 MacLeod men. The most recent mutation that all these men share is called BY3210. Based on this and other evidence, we believe that this mutation first appeared in Leòd himself. Going further back in time, these men all carry three older mutations that first appeared in men born around the time of the Viking invasion of Scotland. Interestingly, a group of men with the surname MacNeil, with earliest known ancestors from Skye, share these three older mutations. Then, two men with recent ancestors from Orkney are found to share the two oldest mutations. And finally, 8 Norwegian men with earliest known ancestors from Ålesund also share the two oldest mutations. We believe that this provides genetic evidence for Leòd's ancestors originating from Norway with likely connections to Orkney. But what about men from the Isle of Man? A separate DNA study of men with ancestors from the Isle of Man show very different genetics. One group of these men descend from one man of Norse descent, but their genetics are completely different from the genetics of MacLeod's. Therefore, based on genetic evidence, we support the view of authors, including Andrew MacLeod, that Leòd's father was not from the Isle of Man. Instead, Leòd's paternal ancestors were of Norse descent with likely connections to Orkney. Let me now introduce the concept of genetic benchmarks as we look at the DNA of Leòd's descendants. Today, we know of just a few Y-DNA-tested MacLeod men who have unbroken lineages leading directly to Leòd. Their Y-DNA mutations provide the MacLeod clan with what I call genetic benchmarks. And it's these benchmarks that firmly anchor the genealogy of the clan to the genetics. We'll see how these genetic benchmarks can help others connect to their MacLeod roots. Let me explain. At the top of the tree of Clan MacLeod, we find 4 key genetic benchmarks. As we've said, we believe that the mutation BY3210 first appeared in Leòd himself, which is therefore perhaps the most important genetic benchmark. We know from the history of the clan that Leòd had a son named Tormod. At this point, the clan split into 2 main branches, the Harrison-Dunvegan branch and the Lewis and Raasay branch. Based on 34 Y-DNA tests, All MacLeods descending from the chiefly line of the Harrison-Dunvegan branch carry a mutation called FTT137. We've assigned this mutation to Malcolm, the third chief of the Harrison-Dunvegan branch. Then, based on 72 DNA tests of MacLeods descending from the Lewis and Raasay branch, we find that they all carry the two mutations shown here, FTT138 and FT6192, which first appeared in Torkel Og, the first chief of the MacLeods of Lewis. We'll see a lot more of this mutation and Torkel Og in later slides. Let's now look at three MacLeods on the Harrison-Dunvegan branch. I call these Glengarry MacLeods because all three have recent ancestors from Glengarry, Canada. The history of the Glengarry MacLeods is well known. In 1793, Alexander MacLeod led a group from Glenelg in Scotland, and after many trials and tribulations, they settled in Glengarry, Canada. These three MacLeods have unbroken lineages leading back to Leòd through the MacLeods of Waternish. Therefore, their results provide genetic benchmarks for others whose genealogy is less clear. Here I'm showing parts of the genealogy of James Duncan MacLeod, or Jim, a long-standing member of Clan MacLeod Society of Canada. We see that Jim is a close relative of Alexander MacLeod, the pioneer who brought the group to Canada. Starting at the top, we see that Jim carries the benchmark mutation tied to Leòd and the mutation uniquely associated with the Harrison-Dunvegan branch. Then he carries more recent mutations that we've assigned to William, the fifth chief, and later MacLeods of Waternish. On another branch, we see Ian Duncan MacLeod, a member of Clan MacLeod Society England, and John Malcolm MacLeod from the U.S. Their lineage leading back to Leòd is the same as Jim's in the early years, so it's very encouraging that they all carry the same mutations. They also carry a more recent mutation associated with their branch. These three men know their MacLeod genealogy, so their Y-DNA test results can help others. In fact, there are 10 other MacLeods in the project who carry the mutation that we've linked to William the fifth chief. If this linkage is correct, these 10 MacLeods can claim descent from William. Let me now show you an example where the genetics has uncovered errors in the genealogy shown in a well-known publication. This is a pedigree showing the descendants of the same William, the fifth chief, that we saw in the last example. This chart is from one of Alec Morrison's books on the genealogy of the MacLeod clan. William, the fifth chief, is right here at the top of the chart. On the bottom left, we see Roderick, the tea merchant of Edinburgh. His ancestors go at least as far back as Murdoch, the third of Trumpin. On the bottom right, we see Dr. Alex C. MacLeod, the well-known former president of ACMS. His ancestors go at least as far back as Murdoch. As this chart shows, both men are depicted as direct paternal line descendants of William, the fifth chief of Harrison-Dunvegan. But is this correct? Starting with Roderick, the tea merchant of Edinburgh, he wrote that my father came from an old family of the MacLeods of Lewis. My ancestors had Trumpin and Waternish for many generations. Surprisingly, Alec Morrison wrote that Roderick was confused and showed him to be a descendant of a chief on the Harrison-Dunvegan branch. In fact, Y-DNA results from a MacLeod relative of the tea merchant showed that Roderick was right all along, and he descends from a chief of the MacLeods of Lewis. I guess that Roderick wasn't confused after all. Next, let's look at Dr. Alex C. MacLeod. Dr. Alex had a distinguished medical career. He was president of ACMS for 8 years, and among his many accomplishments, he actually started the MacLeod DNA Project over 20 years ago. The issue is that based on his Y-DNA test results, Dr. Alex is in the so-called R1A genetic group. This was one of those 4 groups who were not direct paternal line descendants of Leòd. So Alex does not carry the benchmark mutations linked to the Harrison-Dunvegan chiefly line. Therefore, Dr. Alex and his ancestor Murdoch are not descendants of William, the fifth chief of Harrison-Dunvegan. Given all this, we can say that this chart by Alec Morrison is mostly incorrect. Let's now look at the Lewis and Raasay branch of MacLeod, where we have more test results and some clearly defined subbranches. As mentioned earlier, we've assigned the mutation FT6192 to Torkel Og, the first chief of the Lewis MacLeods. We find that the 72 MacLeods who carry this mutation can be placed into one of 5 genetic subbranches descending from Torkel Og. Each of these subbranches is defined by their own mutation. To try to make things a bit easier to follow, we've numbered the subbranches from 1 to 5. Our next challenge is to try to figure out the names of the men who were first born with each of these mutations, but we know for a fact that they all are descendants of Torkel Og. In the next set of slides, we'll share our current thoughts for the first 4 subbranches. We're still trying to figure out who started the 5th subbranch. There are 8 MacLeods in branch 1, and they all carry a mutation that first appeared in a man born around the year 1500. One aspect that is unique about these 8 men is that their earliest known MacLeod ancestors came from the area around Assynt on the mainland of northwest Scotland. If we look at the history and genealogy of the chiefly line of Lewis MacLeods, we see that Norman MacLeod, grandson of Torkel Og, was the progenitor of the MacLeods of Assynt. Given the estimated age of the mutation defining branch 1, it may be that it first appeared in Norman's grandson, Angus More, third of Assynt. Branch 2 includes 30 MacLeod men, which makes it the largest of the 5 subbranches. The mutation that defines this branch first appeared in a man born around the year 1400. Many of these 30 MacLeod men report earliest known ancestors from the Isle of Lewis, and some were even born on Lewis. Therefore, this branch is the one most closely associated with the MacLeods from the Isle of Lewis and the Lewis chiefs. One of these 30 men is Norman Robert MacLeod. Andrew has traced his lineage back to Old Norman of Uig in Lewis. Old Norman was the progenitor of Clan Tormod of Lewis. Given the estimated age of the mutation defining this branch, it may be that the mutation first appeared in Old Norman's father, a man named Alistair MacLeod, who was the grandson of Torkel Og and son of Rory More, the second of Lewis. Here we show where Alistair and his associated mutation fits in the line of Lewis chiefs, leading to the infamous Old Rory, the 10th and last chief of the Lewis branch of MacLeods back in the 16th century. The Raasay chiefs are known to be descendants of the Lewis chiefs, and most authors claim that the Raasay chiefs descend from a son of Malcolm of Lewis. If the Raasay chiefs descend from Malcolm, and if we are correct in where we've assigned the mutation for branch 2, note that the Raasay chiefs also should carry this mutation, namely FT371272. So let's now look at the genetics of the line of Raasay chiefs. This brings us to branch 3, the Raasay chiefly line. This branch is the smallest of the 5 genetic branches, with only 2 members. That said, we're very fortunate that the 2 members are cousins of Chief John of Raasay. Their shared mutation was likely carried by their most recent common ancestor, a man named Francis Hector George MacLeod. He was the son of James XII of Raasay. However, their next shared mutation is FT6192, which we've linked to Torkel Og, first of Lewis. They don't carry FT371272. Given what we know today, these DNA results better support the genealogical work of Norma MacLeod in her book on Raasay and Andrew Piers MacLeod, where they both claim that the Raasay chiefs descend from a branch of the MacLeods of Gairloch. However, with only 2 members, we clearly need more genetic evidence to define this branch. Here we see a high-level view of the Raasay chiefly line descending from a son of Torkel Og, born circa 1362. Members of this branch of MacLeods were once on the mainland of Scotland, around Gairloch. Furthermore, there may be a link to Branch 4. Here at the bottom right, we see Sandy MacLeod, who lives on Raasay today. His earliest known ancestor is Alan Ruad, thought to be from the mainland of Scotland. Alan's son John and his wife Margaret Mackenzie are like the Adam and Eve of Raasay, with thousands of living descendants today. It may be that Alan's ancestor was Rory Neviernach, who may descend from the mutation that defines Branch 4. This mutation is carried by 9 other MacLeods, most who have earliest known ancestors from Raasay. So the mutation linked to Branch 4, which first appeared in a man born around the year 1400, may also have originated in Gairloch, with descendants moving to Raasay in later years. Let's now summarize the DNA of Leòd's ancestors and descendants in one chart. We started off by showing that Leòd's ancestors came from Norway, with likely links to Orkney, not the Isle of Man. We said that BY3210 is a key genetic benchmark linked to Leòd. Then we reviewed the genetics of 3 men with recent connections to the Glengarry MacLeods of Canada. These MacLeods descend from the MacLeods of Waternish, who were part of the chiefly line of the Harrison-Dunvegan branch of the clan. Note that there are 2 Harrison-Dunvegan sub-branches that are unidentified. Next, we looked at the Lewis and Raasay chiefly line with its 2 key benchmark mutations. The Lewis and Raasay branch contains 5 sub-branches with likely origins in Assynt, Lewis, and Gairloch. 1 sub-branch is yet to be linked to any early ancestor, but we note that most MacLeod men in this sub-branch have early ancestors from Skye and Raasay, and not Lewis. This is all based on just over 100 YD-DNA tests, so we should consider these genetic assignments to names somewhat speculative at this point. Let's now shift gears and talk about what are called non-paternity events, or NPEs. In the MacLeod DNA Project, we note that there are many men who carry the benchmark MacLeod mutations, such as BY3210, but they don't use the MacLeod surname. Some examples are listed here. There are many possible reasons for this, and the most common is assumed to be infidelity somewhere in the paternal line of the tester. Keep in mind that the non-paternity event could have happened very far back in time. There are many other possible explanations listed here for this surname to genetic mismatch. The father of one member of the project was adopted and given the surname of his adoptive parents. Another member's father was born out of wedlock and given the surname of his mother. It may even be that an early MacLeod ancestor switched clan allegiance and became a MacDonald. Here's another way to look at non-paternity events. If a MacLeod man takes a Y-DNA test and he carries the benchmark mutation BY3210, we can confidently say that he is a direct paternal line descendant of Leòd. As I've said, in some cases, a man who doesn't carry the MacLeod surname takes a Y-DNA test might be surprised that he carries a benchmark MacLeod mutation, such as BY3210. This must mean that somewhere in his paternal line, perhaps far back in time, a MacLeod man who descended from Leòd fathered a child that was this man's ancestor. Equally common is when a MacLeod man takes a Y-DNA test and he finds that he carries mutations that are common to another clan or paternal line. In the Nicholson example, there are 5 MacLeod men in the project who are descendants of the Nicholson chiefly line, and we think the non-paternity event occurred very far back in time. Together, these 2 cases make up at least 15% of the project membership, so NPEs are quite common. Finally, I'd like to talk about DNA testing and the need for more MacLeod DNA tests. This image shows how simple it is to take a DNA test. It's just a simple cheek swab, and you mail it back to the testing company. In this appeal for more MacLeod men to take Y-DNA tests, let me start with a quote. "The gift of the name obligates one to strengthen the ties that bind." These wise words come from Dr. Gustavus Arius MacLeod, speaking of his MacLeod surname. Gustavus is the first and only person to fly over the North Pole in an open cockpit biplane. It's an amazing story. Gustavus strengthened his ties to the MacLeod clan by documenting his genealogy and taking a Y-DNA test that shows he is a descendant of the chiefly line of Lewis MacLeods. I want to thank the current testers. From your results, we are making real strides in establishing the genetic framework of the MacLeod clan. Men who take Y-DNA tests learn about their MacLeod ancestors, and we all learn more about the history and genealogy of the clan. Through Y-DNA testing, we have uncovered errors in the written history of the clan, and we have provided solid support for alternative views on the genealogy of the clan. But our database is small. We have relatively few tested MacLeods on the Harrison-Dunvegan branch of the clan, and many branches have unknown origins. We simply need more MacLeod men to take Y-DNA tests. There are several options for DNA testing that can be a bit confusing. In general, the more you spend on DNA testing, the more you learn. We mentioned at the beginning that the most common type of DNA test is called an autosomal test. Both men and women can take these tests. First, these tests provide an estimate of a tester's ethnicity. For example, it may say that you're 30% Scottish. These estimates are quite popular, but frankly, they provide no insight regarding a person's MacLeod ancestry. The real value comes from the provided list of DNA matches, people who share some amount of DNA with you. These are your cousins, and some may even be unknown close cousins. Working this list and figuring out why they are a match to you will help you build and expand your family tree. For the work you've seen here, we've relied almost entirely on Y-DNA tests. As we've said at the beginning, only men can take these tests. There is an entry-level Y-DNA test that will tell a man whether he is a descendant of the chiefly line or one of the other 4 non-chiefly line groups mentioned at the beginning. Finally, men can take the big Y DNA test, which is the one that provides the Y chromosome mutation information that we've talked about today. If you are in the chiefly line, it will clearly identify which branch and sub-branch of the clan you descend from. One testing strategy that might work for some is to take the entry-level test at the start of your DNA journey and upgrade later to the big Y test if the initial test results are encouraging. Conveniently, the testing company does not need a new sample. But what if you're a MacLeod woman interested in Y-DNA testing? In this case, you'll need to find a brother, father, uncle, or male MacLeod cousin to take a Y-DNA test. Family Tree DNA is running their summer sale right now. If you use this code, MacLeods will get an extra $20 off. We've covered a lot of ground today, and it's time to wrap things up. In this talk, which focused on the DNA of Leòd's ancestors and descendants, we have established genetic benchmarks for the 2 main branches and some cadet or sub-branches of Clan MacLeod. If you take a Y-DNA test and you find that you carry any of these benchmark mutations, you descend from the men linked to these mutations. We have found genetic evidence to support alternative genealogies, such as those related to Leòd's origins. We've also uncovered numerous mistakes in published genealogies. We've informed many MacLeods about their ancestry through reports, presentations, and a published paper. But we need more testers and test results if we want to make more discoveries. From these new tests, more MacLeods will learn about their ancestors, and Clan MacLeod will learn more of its history. I'd like to thank you for your interest in the DNA of Clan MacLeod. In these next 3 slides, I've included selective references that we've used to prepare this talk.